Hello everybody, welcome back. In this lesson we're going to be talking about elimination. So in the last lesson we discussed substitution, which is one of the two methods for solving a system of equations with two variables. So I mentioned earlier that you need to make sure you know how to do substitution in order to do elimination successfully. So if you don't, go ahead and check back in the last video and come back in a few. Now we're going to dive into elimination. Elimination, what is it? Elimination is a method for solving a system of equations by manipulating coefficients to eliminate variables through linear combinations. Linear combinations, well, what's that? That's a new word because we already know about manipulating coefficients and everything. But what is a linear combination? A linear combination means using the multiplication and addition properties to combine entire equations while eliminating a variable. That sounds pretty weird. Let's go through our steps, and then we'll try and see if we understand it with some examples. Steps. Number 1, choose a variable to eliminate. V1 again, just like last time with substitution. Step 2, if needed, multiply one or both whole equations by constants to make the coefficients of the chosen variable negatives of each other. That seems pretty complicated. You're not going to need to do it each time, but it's actually a lot simpler than you think. And this right here is basically the main part of the linear combination. Step 3. Find the sum of the two new equations. In doing so, you're going to be able to cancel out V1 by doing so. It'll make sense in a few. Step 4, solve for V2. And then step 5, plug V2 back into any equation to solve for V1. This right here is why I said you need to be a pro at substitution before you can go on to elimination, because these last two steps are exactly the same as the substitution method. This is also why I said in the last video towards the beginning that I personally prefer to do substitution over elimination, because I feel like it's simpler and there's a lot less things you need to learn. Either way, you're probably going to be tested on both methods, so let's jump into it. Example number 1. I chose V1 to be x. However, with the original equations, we didn't need to do anything for step 2 by multiplying by any constant. Don't worry, in the next question we will need to, but we'll take it step by step. So, step 3, we're going to take the sum of both equations. Step 3, find the sum of the two new equations as it says right here. So we added the two equations and we get y equals 5. Y is now V2. Step 4, we are going to plug it back in, just like in substitution, do the algebra to then find out what V1 is equal to. V1 is 7. Cool. Let's move on to example 2 and then we'll try our own. Example 2. We're going to make x our V1, so we're going to try and cancel out x. But by doing so, we need to make sure that the x values of each other are negatives of each other with the same coefficient. For example, here we get it to equal negative 2x, and positive 2x. We didn't originally have that. We had to multiply the entire second equation by negative 2. So that when you are taking the sum, the entire x values for both equations cancel out. After taking the sum, you get this, negative 2y equals 2. Now step 3, solve for V2, and you get y is equal to negative 1, or V2 is equal to negative 1. Step 3. Now we are going, we've just finished step 3, check. Now we're going to do step 4 and 5, where we go and plug back in our V2 to solve for V1, just like substitution method. So we're plugging back in, and we get x is equal to 6. Here's our solution. Now it's time to go and try some of our own examples. So here we go. I'm going to choose x to be V1. But by doing so, we actually need to multiply this whole thing by negative 2, times by negative 2. So now, we're going to get two new equations. We have, change color, we have 4x plus 8y equals 12, which we are keeping. Now we have negative 4x minus 6y equals negative 12. Fantastic. Now we're going to take the sum of both. So we are going to get 2y equals 0. So y is equal to 0. Check. Now we are going to go and plug this back into any of the original equations to solve for v1, since this is v2, just like in substitution. So we're going to pick an equation to plug it back into. Let's do this one. 2x plus 3 times 0 equals 6. 2x equals 6. X equals 3. Does this question look familiar to you guys? Because the truth is, each of these examples are actually the same examples that we did when learning our substitution method. Look at that. I did this on purpose so that you guys can learn that substitution and elimination result in exactly the same thing. They have exactly the same answers, as you can see here. So, for number 1 of substitution, we got 3, 0. Now, if we go back to elimination, which is this lesson, we also got the answer of 3, 0. So it makes no difference what you do. It more has to do with personal preference. Fantastic. Let us keep going. So we're going to have here, we're going to have to multiply this one times negative 4 because we want y to be v1. Let's solve. We have negative 8x minus 4y equals 6. Then we're going to have 3x plus 4y. Oh, excuse me, I forgot to multiply that. Get negative 24 over here. Great. Equals 4 down here. We're going to take the sum. This gets canceled out. Change color. We're going to get a negative 5x equals negative 20. Divide by negative 5. Divide by negative 5. We've solved x as 4, which is v2. We're going to take v2. We're going to plug it back in. Let's plug it over here. 2 times 4 plus y equals 6. 8 plus y equals 6. Y equals negative 2. Great. Here's our solution. We got the solution as 4, negative 2. Let's just go back and check with our substitution method. Is it the same thing we got last time? Zoom out. Indeed it is. 4, negative 2. Fantastic. Let's keep going. Over here, we're going to have to multiply this whole thing by times negative 2 to get negative 4y equals negative 8x minus 12. Here, you're going to still have 4y equals 8x plus 12. If you guys remember from the last video that this was the one that has all real numbers as solution. So when you take the sum of the two equations, you're going to get 0 equals 0, which is a true statement. So what can we draw a conclusion here? Therefore, when we get a true statement, or a 0 equals 0 with elimination, we can say that all real numbers is the solution. Just like last time. Let's move on. This one was another example of that. However, I wanted to use this example for another reason when doing elimination. In previous examples, we've only had to multiply only one equation. One equation here, one equation here, and one equation here. In certain examples, you may need to multiply two equations in order to get your equations to cancel out. Just like many lessons back when we were talking about LCM. We need to find out what the LCM is. So let's pick one of them to multiply. Let's say we're going to do Let's do the x. So x is going to be v1. So that means over here, let me change color real quick. Over here, we're going to have to multiply the whole thing. First, we need to identify the LCM. The LCM is going to be 12 for the coefficients, or negative 12, so plus or minus 12. So let's multiply the whole thing over here, times it by 2. Then for the bottom one, we're going to have to multiply the entire thing, times it by negative 3. So now we're going to have the new equations of 6y equals 12x plus 24. Then we're going to have negative 6y equals negative 12x plus 24. Here we go. Great. So now we're going to have this and this equals 0, equals this equals 0. Then we have 48. Wait a second. This is a false answer. This is false. Therefore, we know that I'm sorry, I think the computer glitched, guys. Anyways, therefore we know that we don't have to write this. Therefore we know that these two have no solutions. No solutions, because we got another false answer, just like back in our previous questions. Whoops, close that out. No solution. So let's look back at our substitution one. Was this the same one as last time, or did I change this one? 2y minus 4x equals 8. 2y minus 4x equals 8. Yes, I changed this question a little differently. So the other three were exactly the same ones from substitution, but this one was a little bit different. So just like last time when we were doing substitution, if you got no solution that shows up as some kind of a false statement, that implies the same for elimination. So I hope you guys understand that you can't do elimination without knowing substitution, but some of the same rules apply where you're getting a true statement that means all real solutions and a false statement means no solution. So go ahead and rewatch this video if you need for the extra practice, and thank you guys for watching.